Welcome to Edexcel L-Level Business. In this lesson, we are covering Section 1.2.4, Price Elasticity of Demand, a key concept in marketing and pricing strategy that is regularly assessed in both data response and essay questions. In this lesson, you will learn the exact definition and formula for price elasticity of demand, its key determinants, how to classify demand, its value to decision-making, strategies to reduce elasticity, and how to evaluate its limitations. Before we calculate anything, we must understand the fundamental law of demand. This core economic principle states that when the price of a product goes up, the demand for that product generally goes down, and vice versa. While the law of demand tells us the direction of the change, it does not tell us the magnitude. It tells us demand will fall if prices rise, but it does not tell us exactly by how much. This is where price elasticity of demand comes in. By definition, price elasticity of demand measures the exact extent to which the quantity demanded for a product changes in response to a change in its price. Understanding this precise measurement is vital for any business. It allows marketing managers to predict consumer behavior accurately, ensuring that any changes to pricing strategy will ultimately benefit the financial health of the company. The formula for price elasticity of demand is straightforward but crucial for your exams. It is calculated as the percentage change in quantity demanded, divided by the percentage change in price. A common mistake students make is using absolute numbers instead of percentages. You must always calculate the percentage change first. Remember, the change in demand always goes on the top of the fraction. Let us look at a real-world example to see how this formula works in practice. In 2017, the popular pet food brand Shiba decided to alter its pricing strategy in the supermarket. Shiba implemented a price increase of exactly 5% across its product range. As expected by the law of demand, this increase in price led to a noticeable reaction from their customer base. Following the 5% price increase, Shiba's sales volumes fell by 10%. Consumers either switched to cheaper alternative brands or simply bought less cat food overall during their weekly shop. To calculate the price elasticity of demand for Shiba, we take the minus 10% change in demand and divide it by the plus 5% change in price. Let us look at the math. Dividing minus 10 by plus 5 gives us a final price elasticity of demand value of minus 2. This single number tells us exactly how sensitive Shiba's customers are to price changes. You will notice that the result is a negative number. Because price and demand move in opposite directions, the price elasticity of demand value will almost always be negative in your calculations. A value of minus 2 means that for every 1% change in price, the quantity demanded will move by 2% in the opposite direction. The demand reaction is twice as large as the price change. Now that we understand the formula, we must explore the determinants of price elasticity of demand. These are the specific factors that dictate whether a product's demand will be highly sensitive to price or not. The first major determinant is the degree of product differentiation. This refers to how unique or distinctive a product is perceived to be, compared to other options available in the market. Consider the Financial Times newspaper. It offers highly specialized, unique financial journalism. Because it is so highly differentiated, its price elasticity of demand is incredibly low, estimated at around minus 0.05. In contrast, consider a general celebrity gossip publication like Look magazine. The content is easily found elsewhere, meaning it has very low differentiation. Consequently, its price elasticity of demand is much higher, around minus 2. Because Financial Times readers have no real alternative for that specific data, they will accept price increases. Look magazine readers, however, can easily switch to a rival publication if the price goes up even slightly. The second key determinant is the availability of substitutes. If a consumer can easily find a similar alternative product, the original product will have a much higher price elasticity of demand. Imagine buying a Sprite at a cinema. The cinema likely only sells one brand of lemon lime soda. Because there are no direct substitutes available in that specific location, the demand becomes highly insensitive to price. Now imagine buying that same Sprite in a large supermarket. Right next to it on the shelf is 7-Up, and perhaps a supermarket-owned brand alternative. The availability of these direct substitutes completely changes consumer behavior. Because substitutes are readily available in the supermarket, any increase in the price of Sprite will cause consumers to immediately switch to 7-Up. Therefore, the supermarket Sprite has a much higher price elasticity of demand. The third major determinant is branding and brand loyalty. Companies spend billions on marketing to create an emotional connection with consumers, ensuring they repeatedly purchase the same product without question. Strong global brands like Coca-Cola or Harley-Davidson have cultivated immense loyalty. Their customers often buy on autopilot, completely ignoring competitor prices or cheaper supermarket alternatives because they trust the brand implicitly. This intense brand loyalty significantly reduces the price elasticity of demand. If Harley-Davidson raises the price of a motorcycle, their loyal customer base is still highly likely to purchase it, rather than switching to a rival. Now that we understand the determinants, we must learn how to classify demand based on the final calculated number. Demand is broadly classified into two main categories: price elastic and price inelastic. Demand is classified as price elastic when the absolute value of the calculation is greater than 1. This means the percentage change in demand is mathematically larger than the percentage change in price. For example, if a business raises its price by 5% and experiences a massive 15% fall in demand, the resulting calculation is minus 15 divided by plus 5, giving a PED of minus 3. Because the absolute value of minus 3 is greater than 1, this product is highly price elastic. Consumers are extremely sensitive to price changes, and the business must be very careful with its pricing strategy. For products with price elastic demand, cutting the price is usually a smart move. Because consumers are so responsive, a small price cut will lead to a massive surge in sales, ultimately boosting total revenue. Conversely, raising the price on an elastic product is highly dangerous. A small price increase will cause a mass exodus of customers to rival brands, resulting in a significant drop in total revenue. The second classification is price inelastic demand. This occurs when the absolute value of the calculation is less than 1. Here, the percentage change in demand is smaller than the percentage change in price. Products with inelastic demand are often necessities, habit-forming goods, or high-fashion items. Consumers feel they simply must have the product, regardless of minor price fluctuations, making them highly insensitive to price changes. Let us look at a real-world example of inelastic demand. The Daily Telegraph newspaper decided to raise its daily price from £1 to £1.20. This represented a significant price increase of 20%. Because reading a specific newspaper is often a strong daily habit, this 20% price increase only caused sales volumes to fall by 4%, dropping from 604,000 to 579,000 copies. If we calculate the elasticity, minus 4% divided by plus 20% gives a PED of minus 0.2. Because 0.2 is less than 1, the demand is confirmed as highly inelastic. Let us calculate the financial impact. Before the price increase, the Telegraph sold 604,000 copies at £1 each. This generated a total daily revenue of exactly £604,000. After raising the price to £1.20, sales fell to 579,000 copies. Multiplying these new figures together gives a new daily revenue of £694,800. £800. By raising the price on an inelastic product, the Telegraph increased its daily revenue by over £90,000. This represents a 15% increase in total revenue, despite actually selling fewer physical newspapers. This perfectly illustrates the golden rule for inelastic products. Raising the price will almost always boost total revenue. Because consumers will not switch, the higher price compensates for the small loss in sales volume. Conversely, cutting the price on an inelastic product is a terrible strategy. The small increase in sales volume will never be enough to compensate for the lower price, resulting in a significant drop in total revenue. To summarize these critical rules for your exams, if demand is price elastic, a price rise reduces revenue, while a price cut raises revenue. The revenue moves in the opposite direction to the price. And if demand is price inelastic, a price rise raises revenue, while a price cut reduces revenue. For inelastic products, the total revenue always moves in the exact same direction as the price change. Beyond simply adjusting prices, calculating price elasticity of demand provides immense value to business decision makers across multiple departments. It is not just a marketing tool. It impacts the entire operational structure of a company. The first major value is in sales forecasting. Consider the video game company Nintendo. When they cut the price of their Wii U console by 15%, they saw sales volumes skyrocket by 75%. By dividing the plus 75% demand increase by the minus 15% price cut, Nintendo calculated a price elasticity of demand of -5. This proved the console was highly price elastic. Knowing this exact figure of -5 allows Nintendo to forecast the future accurately. If they plan a further 10% price cut for the holidays, they can confidently predict a 50% rise in sales. This forecast is vital for the operations department, who must manufacture 50% more consoles, and the Human Resources Department, who must hire more warehouse staff to handle the increased holiday shipping volume. The second major value is developing an optimal pricing strategy. West Ham United Football Club uses price elasticity data to vary their ticket prices dynamically, aiming to achieve over 95% capacity utilization at their stadium.